The Edifice Complex podcast is brought to you by DCM, the drawing specialists, Blue Rhythm commissioning software, and Sensor Suite, the future of intelligent buildings.
Welcome to the Edifice Complex, the property design and development podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator here with my colleague, official agitator, friend, and Yoda of most everything to do with buildings, Mr. Adam Muggleton. Say hello, Sir Yoda.
Hello, Yoda. So before we get going here, I have to have a disclosure. James, who is on the show today, is a colleague of mine from the UK. He's awesome, but just so you know, we work together, and that's why he's on here, because he's revealed things to me over the last couple of months that I had no idea of, and I'm supposed to know what I'm doing, right?
You're not alone. Not alone, Adam.
Yeah. So our guest today is a highly skilled acoustic consultant with over 18 years experience, providing noise and vibration, design advice, and testing, encompassing planning, environmental, architectural, and building services, acoustics. He's a member of the UK Institute of Acoustics and chairman of the UK Institute of Acoustic Building Acoustic Group. Some of his recent contributions to the field include principal author of the 2020 ANC Acoustic Ventilation Overheating Guide, which is an important document, the 2022 Guide to Demonstrating Compliance with Noise Requirements of the approved document O, and a contributor to the 2022 Future Homes publication Part O, 2021 technical guidance. He's the director of overheating and acoustics with AESG, an award-winning specialist consulting company, engineering and advisory firm. The offices in London and Dubai, which is sometimes why Adam's not around, because he's in one of those three locations. And of course, the company works, I think, almost around the world, aren't you guys? Europe, Asia, Middle East, wherever there's money and problems, you guys will be there.
Wherever the check is waived, we will go and collect
it. Exactly. So welcome to the show, James Healey.
Thank you very much, Robert.
James, between 1996 and 2005, your academic journey took you through the field of sound engineering. You're in a specialized league, there's no doubt about it, working in part to prevent or solve acoustical problems, which, by the way, for our listeners, everybody, we're in COVID times right now. I kind of put some date on this particular discussion. And a large part of the world is focusing on air quality, and no doubt an important element when it comes to indoor environmental quality. But COVID aside, pathogens aside, airborne issues aside, sound is still the number one complaint in buildings today, and has actually been for a long time. Part of that came about from solving IAQ problems, right? Going to more natural materials, concrete, glass, wood, tiles, whatever, right?
Well, the well-being standards in offices were adapted, which took brought in biophilia, stripped out medical type sterilized areas and made them visually appealing, but as a result they made them noisier, and people's noise was the number one problem in offices, and it's gone up, and it is still the number one problem for people in offices, and the same for dwellings. Neighbor noise is the number one issue for in the entire UK, and I'm sure it is in other regions as well.
Yeah, we're going to get into these issues in greater detail, but before we do that, we always like to let our audience know who the heck you are. So tell us who the heck you are. How'd you get here?
How did I get here? Well, you said 1998 to 2005. So that journey, I finished school and I started an engineering course in college. Primarily because I was reasonably good at maths and science, and got bored of it. To be honest, I really got bored of it. And I love music, and I was a DJ, and that was, as a 18-year-old kid, That's what I thought. That's my vision, is music and music production. And I was DJing out in clubs, and I decided I want to be a music producer. So I went and did sound engineering at college, and that was back in the day where the digital revolution was just coming around. 96, 98, 2000, it was just about coming around. So I got the opportunity to actually learn the analog style of way of doing things, splicing 2-inch tape, for example, in recording studios, and recording all sorts of famous local rock bands in the process. But my passion was about sound and music. And that took me through to sort of 4 or 5 years of studying, but in that process, that's something a little bit something sparked in me, and that was how sound is produced and how we experience sound. And I did one module in acoustics. Acoustics is the science of sound, and I did one module in acoustics, and I found it very interesting. But I finished the course. And I thought, right, I'm going to be a sound engineer. Let's see what jobs are about. And there were so many people doing sound engineering. Most people hadn't even gone through a qualification, and it was very easy to get a job in that. And I thought, I want to be more specialised. At the same time, I was witness to some of my family members who were really excelling in. So my uncle is the designer of the 3-platform oil platform in that you see in the sea, and he helped design the Harrier jump jet that takes off vertically.
Cool.
And in his later life, he designed automated vehicles for the Navy, the U.S. Navy. He moved out to the U.S. Before I was born. So I saw some of these people in my family excelling, and I thought, I really need to do something that really pushes myself. And I hadn't gone to university, and that was it. So I got all my partying out of the way until 2000, and then at the age of 20.
I thought you were going to say 2021, but
I still live life to the extreme, but I'm a sensible family man. I joined the university at age of 23. And I did 4 years as an acoustics course up until 2005. So that's how it brought me to 2005. And little did I know that I stumbled upon an amazing opportunity on the basis that very few people study acoustics, and that's declining. And those that do study are becoming, or qualify, are becoming more and more sought after as people's perceptions and expectations increase. And as we get more populated, we stumble upon each other, and noise becomes, like you've highlighted, a big issue. So acoustics I just stumbled upon a career that I enjoy, and it happens to do me good.
Yeah. We did some work for BC Housing, and I remember one of the dialogues that we had with their executive team had to do with natural ventilation. And I said, natural ventilation is all fine and dandy until you open up a window, and then you get the traffic, you get the air pollution, you get the light pollution. It's like, and the sound, like you said, I mean, as the densities increase in areas, whatever it is, rural areas, downtown cores, whatever, noise becomes a huge issue. So it's not only an issue on the outside, it's an issue on the inside, and what's on the outside wants in, and what's on the inside wants out, and and a
lot of people don't really know. So you get a lot of suppliers that supply products, and they just want to sell you the solution of their product. They don't really sell you the solution that is best for the building or for the example. So you get a lot of people that are okay at doing acoustics. You get some people that are good, and some that are exceptional. So. Yeah, it is a skill, and it's definitely a good skill to have. Yeah,
for sure. Well, I know And Adam, I don't want to take all the time here, because what's interesting about this is that when you go to the National Building Code of Canada, there's a requirement, that the building should be designed to limit the probability that people will get ill as exposed to moisture, bad air quality, and thermal issues, and put brackets around that statement. But if you dig deeper, there is a requirement for sound analysis.
Mm-hmm.
But it seems to be like this small little sentence that just sort of hides within the millions of sentences that are in the building code. But it's a requirement to do sound analysis.
I bet you that gets skipped over because it's not brought out into the forefront of the regulation.
Yeah. So you can actually, now everything's in PDF, right? So you can do a word search and you can do sound, and the building code will actually addresses it, but no one does it.
Back in 2012, the government in the UK got rid of all the red tape for planning requirements, and prior to that, it was very prescriptive, and it said thou shalt not build sensitive residential properties in where you're exposed to this decibel of noise. The government scrapped all of that. And left it with 3 bullet points in the planning policy that related to noise, and so our industry took it upon ourselves to reintroduce what we thought was an appropriate prescriptive approach, which gave more flexibility. But there's so many regulations across the world. And some countries do it very well and very prescriptive. And the UK is very prescriptive now in the approach. But there are a lot of other countries. The Middle East, it's a bit hit and miss. Dubai is very good, for example, it is really hit and miss. And I'm not sure what it looks like in Canada, but it can easily get missed. And it's strange because it's the number one issue that people experience when they're living in their homes or in the offices.
Yeah. We're in an interesting time, right? I think there's actually a slow motion train wreck going on in our business at the moment. So typically, let's talk about residential, but it applies everywhere, right? We control based on temperature, right? And, it's not even mean radiant temperature, right? It's just temperature, right? So we control on that. Yet ventilation requirements are now in the public awareness, right? Because of COVID. Pollution, people are more worried about pollution issues, right? Then there's temperature and comfort issues. Then you throw in IEQ and IAQ, which people are becoming more aware of now. And sound becomes an issue. Now, sound is one of them things, it's a bit like plumbing or printed circuit boards. You don't care about it till it hurts you or really irritates you. Right? Then you really, really care about it.
Yeah.
And what's happening is, I think, as a public awareness has come in and people are trying to do things and performance is becoming an issue, there's this just crash going on. These conflicting requirements are going to have to work themselves out. And sound is a big factor in that no one's talking about.
I'll tell you why it's such a big factor, Adam, and not because because I'm passionate about it. It's massive because, and the same with air quality to a certain extent, although that's improving. But it's massive because it's not relating to it's not relating to the building itself and how you build it. Because sometimes you need solutions that would by themselves not let sound in. It's actually related to the environment and the design of the environment. So it comes down to bigger picture policy, really, in a lot of cases. And in Europe there is a policy to at least declare and identify. When I say Europe, I'm including the UK. Identify places where sound doesn't feature. Or features less, and they're labelled tranquil areas. I
have some tranquil areas in the UK. They're definitely not tranquil.
No, yeah, but yeah, it's a challenge because it's not something that is easily controllable. Is what I'm saying.
So one of the insights and sort of bits of knowledge you've been dropping on me over the last few months is, climate zone is an issue, right?
Yeah.
And sort of like density is an issue, right?
Yeah.
And so what might be a problem, say, in London or Toronto is not necessarily a problem outside Calgary, or in the wilds of France. So there is a application level to this as well, right? So just give us a bit of background. So for our audience, the UK building regulations have been overhauled. Now, the UK building regulations are quite stringent anyway, and they've been overhauled and are completely being overhauled continually all the time as the government's moving towards their net zero obligations, which I think is now policy. And there's been a recent update to building regs. So if you could just tell us about the background of that, and then what it means and what you think it's going to consequently deliver. So
in countries where it's hot anyway, the people have designed buildings differently, and where it's naturally very cold, people produce a different design. In the UK, we've got traditionally we've got a fairly tempered summer, but a colder winter, and since the 60s, the regulations for residential properties have increased in terms of thermal performance, trying to improve thermal performance to try and reduce energy consumption. And that's great, because we need to reduce energy consumption. That's exactly what we need to do. But as they've gone through, and there was a huge change in the 90s, and then got very prescriptive in early 2000s, and with that prescription introduced requirements for thermal performance of dwellings, and indeed a huge army of energy assessors was born from that huge change in 2006. And then it kind of stayed as business as usual. And what happened was we were making our properties very much less air permeable, less air leakage, more airtight, better thermally performing. Energy consumption was reducing, but at the same time, we're quite a dense population. So you have got, the majority of houses are built on open sites, and the majority of dwellings are built on sites that aren't that densely populated, but actually a lot are also built in city centres, in town centres, and apartments and flats, and you're packing things on top of each other and increasing the thermal performance, reducing air permeability, and ventilation was kind of on the side. And there was nothing at all in any regulation except in what we have as a Housing Act, which is kind of like a health and safety feature which environmental health would enact if there was a real problem. There was a little reference to that since 2005 to do with thermal comfort, but nothing really thought about thermal comfort. And all the time we're making these properties hotter and hotter and hotter, and people are experiencing real problems as a result. And all of a sudden, the government realised actually we need to deal with this. So they did some research. So the reason why I'm involved in this in the first place is that there is an assessment method to assess overheating in properties, and people do use computational modelling. They predict what if it's above a certain threshold, it's going to overheat, and then you devise a solution to solve it. So normally the process is that you get heat gains, solar gains, and internal heat gains as much as practically possible, and then you remove excess heat when you can. And normally the default solution has been in the UK to just open your window. And that is pretty much the solution when you haven't got air conditioning anywhere in the world. It's just open your window. But and there's nowhere in the world that has really thought about this except the UK. And in 2016, we formed a committee because people were opening the windows and then saying it's too noisy to sleep. I can't sleep, but then I close my window and it's too hot and I can't sleep. So and sleep disturbance is the number one effect on health across the whole of the world in terms of noise. So noise-linked sleep disturbance is the number one health effect that reduces people's life expectancy as a result. That's publicised in the World Health Organization. So people are people are getting disturbed by sleep, and they've got this problem where normally noise assessments say you need to close the windows because it's too noisy, and normally overheating assessments say, okay, we've reduced the gains as much as possible. Now crack open the windows, and the two have been mismatched. So we formed this committee to actually draft guidance to consider all of it holistically and ventilation. And at the same time, we realised that everyone in the industry really doesn't understand ventilation or overheating at all. So
check true.
Yeah, we've been on this educating mission for the last 8 years, and trying to educate our industry and then educate other industries about the significance of this. And the government realised that, well, we've got this problem. And they did their own studies back in 2019 and they figured out, oh, we've got this housing stock and it's overheating, and we need to find a solution for it. And that's then led to the regulation. So the regulation was released, and it pulls on national guidance that we produced in our committee, and it pulls on other guidance that we produced from other committees, CIBSE, for example, in the UK. And I don't think there's anywhere else in the world that has, and we did the research a few years ago when we were producing this guidance document. There's nowhere else in the world that really considers this holistically at all. Everyone, I don't think there's much on the way of overheating elsewhere in the world, and everyone still thinks in a siloed approach of thinking, okay, I've got to deal with my ventilation. Oh, and I've got this other thing, noise. I've got to deal with noise, and you've got someone's a ventilation expert dealing with ventilation. You've got someone who's a noise expert dealing with noise. And then you might have someone that's dealing with overheating, and nowhere does it, fit together. And we all know that they're all one combined intrinsic related element that is basically our indoor environmental quality.
Well, the human body can't separate them.
No.
And again, I'm going to take this opportunity again to just educate our listeners, is that when we use the term indoor environmental quality, so many people use that as a proxy for air quality, or they use the term indoor air quality as a surrogate for IEQ, and that is so wrong. And it's actually created a whole bunch of problems for us that understand that IEQ is actually the sum of all of the environmental sensory systems that the human body has. It's really important to understand that we're talking about light, sound, odors, vibration, thermal, air quality. It's all of these things combined. And you can have perfection in any 5 of the 6 metrics, but if one of the metrics is a mess, people will complain.
Yeah, and that's best. That's visualized best in a spider chart, Robert. I have this vision, and it's not been realized yet. Is that we have a spider chart of all the environmental qualities on points, and the ideal solution is you've got a complete circle where everything is matched.
Yeah, so it's as round as possible. Yeah.
Round as possible. But very, very, very rarely will you get that, because you've got.
And I teach that in my courses, and we actually have a spider graph for it, but we use it more in terms of, well, we have the metrics, but we also define it as stress. So the response to bad sound or bad thermal environments or bad odors is stress in many different forms, right? And you get physiological stress, you can get psychological stress, or get both. And so the spider graph represents the different metrics, but in terms of levels of stress. And you're right. I mean, the perfect one would be a circle, but my God.
Well, you throw into that mix that people understand about air quality and the effect on humans. That's been relatively well researched. There's growing research, but not anywhere near enough on the thermal effects of people when they're and how they respond. There is no research, except for the work that we've done, no research to look at how people respond to noise as you get increasing thermal discomfort.
Yeah.
So or indeed any of those other metrics. Noise is dealt with solely by itself. People nobody understands how people behave. Where would they accept a higher noise level in place of lower thermal comfort or better air quality? None of that research has been done.
And this is where I'm a firm believer that we have to, and we are actually, there's down in Australia, the use of neuroscientists and looking at neurological responses and using things like QEEG technology, which has been used in other areas of medicine. But we should be able to, in a laboratory, and there's like a hint that this is going on in some research projects, but be able to take a brain, and I use the word normal with sort of tongue in cheek, but a brain that can have a signature that represents what a normal brain would represent in an ideal space, where all of the indoor environmental metrics don't lead to over stress responses, right? And then we should be able to take and elevate noise in a space or the thermal environment or the light, and then watch how the neurological response is to those systems. And through that, be able to define, well, what is good stress and what is bad stress? Because we do know in the thermal environment, terms like alloesthesia, where, it's suggested, and to some degree, it makes sense, where some thermal stress is actually good for the human body. If you think about muscle reaction in a professional athlete, right? How did they get so good in balance? It was by being out of balance.
Yeah, but what happens in that situation where you've got other factors thrown into it?
Exactly, right? Yeah.
Who knows?
So I think, we unfortunately, I'll be dead by the time. One of the challenges with using the neurological sciences is that it's pretty easy to connect a brain to a computer within a laboratory setting, but to get someone to walk around in an office environment. Yeah. So wearable technologies that can do studies at a neurological level, that will be the next, I believe. There will be. For years they've measured, used EEGs for sleep disturbance. Yeah. But wearable tech is definitely the way it's going to go. And actually, smart buildings that can determine conditions, and wearable tech that determines response is definitely the way it will go. But we're way off that. I do know studies in the UK that are looking at people at the moment, literally this summer, looking at an occupant's response to heat. In terms of how much ventilation they use and what noise level they're exposed to. There is that research going on, but it's few and far between. Yeah. And as I say, it's not picked up worldwide, because when you get south of say France in Europe, south of France, people are used to dealing with heat, and they've got measures in their buildings to deal with it, and so it's not so much of an issue. And as you get further north, maybe north of not there isn't much north of Scotland, but further north in the northern hemisphere, this strip of north, it's not so much of an issue as it is, for example, in England or in France or any of the other countries. And nobody really has tackled this problem until the UK or England has come along. And
so in Europe, there's a band, right, that sort of goes through sort of Northern Western Europe or Eastern Europe as well, where this matters, right? But what I was thinking of when you guys were talking was, like temperature and sound. Let's just talk about it. And ventilation rates. Let's talk about them, right? Sound and temperature are used as forms of torture, so they freaking matter, right? Do you know what I mean? So if you're even just getting an imbalance, a slight effect from sound, if you have a long exposure to that can be quite devastating, right?
A long-term higher exposure to noise. The side effects. So the side effects are hypertension, cardiovascular problems, all of the heart or health, breathing-related things that could come as a result of knock-on effects from stress or sleep disturbance. all of those things, directly affect your health. And it's not like it's, easily translatable like fire when you burn and you die. But these things reduce your life expectancy, and that's how the World Health Organization measures it in disability adjusted life years. That's how they measure the effects of noise.
Yeah. I've been in a room that removes sound, and that is also equally disturbing. Like, it's actually really bizarre to be in space where
a fully anechoic chamber.
Yeah. And it was actually nauseating.
Yeah,
I worked in a laboratory for a year where there was the biggest anechoic chamber. I think it was in Europe, maybe even the world, where you could build an entire house within it. And that was very strange because of the volume you can see with your eyes and the sound experience, which was completely mismatched.
Yeah.
See, that is a form of disorientation. I mean, I did a LEED Platinum job in Canada, and it was a displacement ventilation job, thermal mass, radiant heating and cooling, and it was quiet as hell. And we got so many complaints on noise, we had to put white noise generators in.
You do. Well, that's a common problem with. In fact, that's the biggest problem with offices is that people build offices. And then they design the services systems, even if it's ventilation or cooling mechanical systems, they're over attenuated, and you end up with a lower noise level, and as a result, you get speech distractions because people can hear the other person talking across the other side of the office, and then that's the number one complaint of people is actually disturbance from their fellow employees.
Yeah, so there's a productivity tied out, but I think the most important connection to be made here is the effect to health, long-term health, right? You know, long exposure, even to something that's off a little bit, can be detrimental to your health, to your heart health. You know, it sounds ridiculous, but my wife's so people are either NLP and you now here, right? So your prime sense is like visual, auditory, or sensory, right? So my wife's prime sense is auditory. I can tell you, man, she can hear me whining at about 100 yards. And if your prime sense is auditory, this is literally torture for you.
Yeah, absolutely. Well, there's a reason why people are wearing headbuds and earbuds in offices. Do you know Jennifer Veach, NRC Canada, sound expert? No, you really should
connect these guys.
Yeah, we've had her on. I'll connect to Jennifer. Yeah, I will.
Yeah, we've had her on the show before, and I, next time we run into her, I'll even send her an email. Just the consequences of noise problems in offices and people's response system when using headphones and earbuds. What's happening to people's sound ability to hear because they crank up the sound and they're at sustained levels for so high because they're trying to drown out the environment.
There's been a lot of research on that on London Underground, where because people have raised their levels of listening, on an iPod or whatever, to drown out, to mask the effects of the noisy underground trains. It gets to a point where even traveling for 45 minutes or an hour on the underground would trigger hearing trigger hearing threshold and hearing damage.
I believe it. Hey, Gleck, go so many places.
I know, I've got so many questions fired in my little brain at the moment.
So when you think about vernacular architecture, let's go back several thousands of years, and overheating was a problem thousands of years ago as it is today.
Yeah.
But when you go into Iraq or Turkey or anywhere where it's just brutally hot, Middle East, the architecture of the day, worked. The clothing, the combination between architecture, using basic Bernoulli, right, in terms of natural ventilation of their buildings, light clothing, reduced opening,
concrete, thermal mass.
Yeah, all of that stuff.
Shading.
Yeah, and then it works until you try to export vernacular architecture from one part of the world to another, and then now you have problems. What happened James, like what happened with all of a sudden, 2,000 years, 3,000 years ago, people sort of figured out because they didn't have AC, there was no compressors, there was no refrigerants, right? They had to figure out a way even to make ice. Like when you go into Persia back, like 2,500 years ago, they were making ice at night using night sky radiation, right? What the F happened?
Well, I'm sorry to say this, but engineering happened.
You're right.
It is, and we designed buildings that looked different, but to compensate, we have to put systems in. But people are still used to dealing. If you go to, I mean, most buildings are air conditioned. Most offices, for example, where it's regularly hot. Spain is a really good example because you do get air conditioning, but they've got all sorts of features within the public realm and within the building design, which reduce the need for that. So they've got shutters on the outside. You're used to seeing shutters in Spain. It's fairly standard. There's lots of trees along the streets for shading. The buildings are light coloured. There's all sorts of these features which are standard in the architecture, and that's how people design and build things in Spain, which are completely alien to somewhere like the UK
or somewhere in America. Like before, retired practitioner here, right? And the dialogues that we would have with our clients, which always started with property, the actual land itself, orientation of the buildings, and then we would get into external shading, right? And then we'd start to try to introduce the concept of, well, keeping the sun off the building is a really smart thing to do. It's not a new idea, right? But then when you start to talk about shutters, it's like people go, what? That's so old. You know what? It's simple, it's stupid, but it absolutely works. And all you have to do is go to places in the world that use shutters. And I think, Spain is a good example. Italy is another great example. I remember the first time I landed in Italy, and I'm walking around. The buildings are conservative, small apertures, shutters on the outside, light, bright colors. Yeah. It's not difficult concepts, but here, particularly in North America, I know you two guys have your roots are in the UK, but you've got
metal facades, glass facades. It's completely different feature.
Yeah, and I use the word illiteracy, and I've been using that word illiteracy for so long now because there's no other word that describes the illiteracy that our society has when it comes to architecture. And I'm talking about people on the street all the way up to architects and engineers and property developers and you name it. There's just a huge illiteracy that occurs. When you go back thousands of years, that's actually when the books, if they were writing books at the time, 3,000 years ago on architecture, well, I guess, was it Vitruvius? Publishing
just
books.
Take the Romans. Engineers were spears. They had it solved. Radiant heating, natural ventilation. Do you know what I mean?
My God.
They can even build straight roads.
Throw away the modern textbooks because it's crap. We're teaching people how to build bad buildings.
But this is a really exciting time. I see that as an opportunity. This is a really exciting time because it's serious. It's really serious because we're now talking about this because of climate change, and we're talking about this because and everyone is focused on reducing the impact of reducing the severity of climate change, going net zero, reducing carbon emissions. Everyone's thinking that along those routes right now, which is great. But what we're actually talking about is dealing with the effects of it when we've got it. And we're going to have it. We're going to have climate change, and we're experiencing it more often now in the UK. We're on our second heat wave of the year already, where we've got mid-30s. In July, we reached a peak of 41 or 40.6 or something in the UK, which is unheard of before. It's a record. And they're just and it's going to be the same in North America. They're going to be you're getting heat waves and you're experiencing this, and they're going to become more frequent, more severe, and actually we've got to figure out ways of dealing with it. And that presents a really great opportunity for people like us because we've got this. In the end, we are engineers, and we've got this engineering problem, and we've got to find a solution. But we've got to think about people at the heart of it. And so there's been lots of research done before, but there's actually so many gaps that need filling, and we're there to fill those gaps.
The Edifice Complex will continue in just a moment.
Can you find the drawing and supporting documents you need in less than a minute? Now you can with Echo. It's simple. Just type what you're looking for and press enter. Echo knows your building. Speak with a drawing specialist today. Ask about our special offer of painless onboarding plus 6 months free with Echo. Visit podcast.thedsoffer.com. That's podcast.thedsoffer.com.
And now, back to the show.
Yeah, I think what we're saying is, climate-wise, there's going to be higher highs and lower lows and more volatility, right?
Yeah.
But I think the engineering solutions are here. What we need is a cultural change of mind, right? So to Robert's question earlier, what happened? What happened was the 1950s and 60s came along and we thought we nailed it, solved it. We are the best. Air conditioning, shit out of everything. Energy's cheap, right? And that mindset still persists in North America. It's 21 degrees plus or minus 1 degree. Thank you very much. And they just run that sucker and keep that going. Yeah. Whereas in Spain or the UK, you have an outside air reset and you could let that temperature rise to 26, 27 degrees if outside is 40 and you'd feel awesome, right? Mm-hmm, mm-hmm. But North America, Canada and America has been so spoiled for cheap energy. People lose their minds here when energy prices go up. If they ever went in the UK and saw how much it costs to fill up a car with gasoline, they'd lose their minds. Their heads would explode, right? Yeah, so there's a cultural reset that has to happen. And what I think is happening is this car crash is happening right now. So,
can I say something controversial there? Go on. I don't think we're going to get around the fact that we need to use energy to solve these problems.
You're not.
We do need to use energy, and in fact, we probably need to use a bit more. But the problem is fossil fuel energy, and if we can make energy that's renewable in abundance, then we can use the energy to solve the problem. But actually, what we need to know really is what problem we're resolving. What target are we going to strive to? Because at the moment we don't know. We don't know how people behave or how people react to different environments and different situations. And so, how on earth are we going to design these, the way we live or the way we work to cope with that? We know that we're comfortable at 20, 21 degrees. We don't know what point we need to start thinking about trade-offs. And all of those things have a real direct consequence on how much energy we use now, how we behave. So I do think that the future is more energy, but actually renewable, locally generated, and actually non-fossil, which that's the future.
That's the whole story on decarbonization, electrification, right?
This is what's going to happen. The only thing that's going on at the moment is no one's accepting it. It's going to be nuclear. The base load has to be handled by nuclear power, and then renewables will take the peaks and troughs. That's what will happen.
Well, I can't say what.
Adam, French. Every once in a while, Adam introduces the N word, and it's not good because.
And you know what we could do with that waste? We're going to say, Elon Musk, stick this in your rocket and send it out to ET. That's what's going to happen with the waste.
But I mean, the mindset, in the UK at the moment is very much. And I don't know how standard air conditioning is in North America.
Everywhere.
It's everywhere.
Well, and it's going to get worse.
Yeah.
But in the UK, there's nowhere. You've got air conditioning in offices. There are very, very few properties, except for London, where air conditioning is often installed. And everyone in the entire UK is still building properties without even thinking about this. Even when the regulations passed, they're still building stuff, and it's quite clearly non-compliant. So that there's going to be a whole heap of lawsuits, I think, in a couple of years when people realise there's a regulation to protect them and people aren't building to it. But it's slowly getting understood, but it's really, really, really taking a lot of time because, as Adam said, it's a fundamental change in perception and mentality and how you approach these things.
But in an ideal world, you're designing for well-being first, right? You're working back from that.
Yeah.
And that spider graph is as round as possible, right? Now, the only way that's happening, says the libertarian, is with government regulation. So I actually am on board with what's going on here, because the only way you get that change is to force it, really.
Yeah. Well, one of the things that we identified when we wrote our guidance document was it was a guidance document by our industry, but it had no teeth.
Yeah.
And the only time it got teeth was when local authorities would require it to be considered in a planning application, for example.
Yeah.
It had no teeth, and that's why I referred back to the Housing Act, because that was an act of Parliament in the UK which mandated people to consider it, but it wasn't widely used. So whilst it's a difficult thing to lump into the I don't know what that you have in North America for people that oversee code compliance. Are they in the UK? They're called building control officers.
They're called co-compliance people here.
Co-compliance. So
and they can be from the city or they can be independent. There's sort of some self-certification movement, but it's not.
Yeah, and that's the same in the UK. But they have to know a lot about everything, and that's impossible, really.
Yeah.
So and as these buildings get more complex, we're requiring them to know even more and more stuff, and all that's happening is that in fact the law is changing in the UK to place the onus on the developer and the consultant to comply. And actually, when someone says you comply with building regulations, we'll give you sign off for your application to build. There's a clause at the bottom that says, by the way, the onus is on you, and this doesn't constitute a statement to confirm that you comply with any of the regulations.
The clause.
So that really just wakes everyone out. Should wake everyone else up, and that's come as a result, as Adam said right at the beginning, of the Fire Safety Act, and the changes in the UK from fire safety perspective have placed the requirements on the developer and the consultant to design appropriately. And I'm sure that mantra. Well, I would expect that mantra to follow elsewhere in the world when these as our buildings get more complex and we're requiring people to think about rubber stamping stuff that they just don't know about.
Well, that's got to go away. There's got to be consequences for that. But what I want to get to is when you and I were in Avison Young's office the other month and telling them about this new land that was going to come and affect them, what I was struck by was there's consequences to this document now, right? This document is a building regulation or building code document. You can't ignore it, right? You got to comply. Yep. And one of the things I took away, rightly or wrongly, was we're going to wind up with more mechanical ventilation, possibly air conditioning, right, to comply with this. So
we will, because as soon as you open the window to remove excess heat, you let noise in. And if you let too much noise in, it's going to be above a level which is acceptable. Now, the government chose a level, noise level, informed a little bit by the work that I've done. But in effect, they've chosen that threshold. And as a result, you can't open your window in anywhere where it's moderately noisy, and the solution, because we're talking about removing excess heat, we need airflow, we need passage of air or tempered air. We need passage of air, we need air movement or tempered air to actually solve the problem. And the open window does that to a certain extent, but actually when you close it, you've got a real problem. And the only way to solve that is actually have, either extract ventilation or supply. Normally, extract ventilation increase rates with openings in the facade to permit makeup air of replacement air as you're extracting the air, and that will. The problem you've got, of course, is you're putting an opening in the facade, so you've got this acoustic challenge where you've got to design acoustic openings at the same time as mechanical systems that are extracting air at much higher rates than we're used to for background ventilation.
So there's there's an energy penalty there. There's also, you can't half-arse it. You've got to design that duct so it's not noisy, right?
Yeah, because there's no point in turning on your fan, because you don't want to open your window and be exposed to the same noise as you would be if you're opening your window.
Yeah.
So you expect, and users' expectations are, if they've got a building that's been designed to cope with this situation, they're going to expect the building to perform appropriately in all conditions. So you can't have a really high noise level when you've got this system in place. And you're talking about high extraction, 30, 40 litres a second per room. It's not a small level of ventilation. And on top of that, in some situations, when the solar gain or the heat gains are too much, mechanical extract isn't the solution. You need tempered air. You need an air to be feeding air into the room that's a lot lower temperature to push hot air out, and that is the conundrum, is that actually our buildings aren't at all designed for that at the moment, and it's going to take a wholesale change in the way people approach it to actually think, okay, I'm saving energy. All the other regulations are about reducing energy, reducing consumption. But we've got to deal with the problem at the same time, so we might have to actually offset that by with some energy consumption, which places more stricter requirements on the levels that you're taking to reduce the energy. So it's a whole thing which is people have not understood and not really taken on at all.
Yeah, just to give again our audience, because we have a worldwide audience, a great example of the domino effect here was Vancouver the last couple of years, and due to climate change as a consequence. By the way, that's my get out of jail phrase. Climate change is a consequence, because I know shit about climate. I know, but when there's changes of consequence, we need to pay attention to it. Anyways, climate change is the consequences that ultimately led to hundreds and hundreds of people dying, and in part because the buildings weren't designed to deal with the changes that are occurring. And so quite concerned, the government in British Columbia, and as they are in other parts of North America, with the existing inventory of architecture that just it's not adaptable.
Have they done anything about it though, Robert?
No, so that's one of the big things right now, is how do we deal with the existing inventory, and not only in terms of architectural but also social systems. So one of the problems that they had is that there were so many people that were called in due to heat stress that the response system, the healthcare response system, was just not adequate enough, and people ended up with heat strokes and ended up dying in their homes because people couldn't respond fast enough.
Yeah, I don't know what the statistics are in Canada, but in the UK, on average, there's about 2,000 heat-related deaths a year.
Yeah, that's just insane.
Yeah, and if they did nothing, they found, their research shows that if they did nothing to the housing stock, that would rise to 7,000 heat-related deaths by 2050.
Yeah, so it's a huge problem, and so and one of the solutions, or one of the response systems that you get is, well, then we have to encourage people to use air conditioning. Well, as soon as you encourage air conditioning, now you've increase the demand on the power systems, right? So now where's that power generated? If it's fossil fuels, that's a mess. It's got to be non-renewable. So, but one of the things that still, and it irks me, is that some of these people that passed away, they didn't have to, and it was the fact that people did not understand that if you could move people to an underground parkade on the north side of the building and plug in a few fans, you could have been in spaces that were, say, if it was 95 or 100 degrees Fahrenheit outside, underground 5 feet on the north side of a building with a fan, you're going to need to put a sweater on.
Yeah, and you'll get these cool islands that will, or community cooling spaces that will be popping up more often.
Right.
I think they've got that a lot in North America. That's fairly standard, I believe, to have community cooling spaces.
Isn't the answer here also earth cooling tubes, like you're dragging air, through a duct underground where it's reliably 55 degrees F, you bring it up.
Well, it is. It is, but actually, that's really expensive to do, Adam, because you've got to dig up all the ground to bury tubes.
Yeah, one of the challenges also with is actually microbials, and ideally, what you would do is actually have a cooling coil in the intake of their HVAC system and use the ground to cool the coil rather than dump the cooled air directly into the space, because some of them are done poorly and they can create air quality problems.
Well, in the UK, the government's chosen to go down the heat source route, the heat source pump. So that's dealing with winter is in any energy efficient way rather than ground source. But actually, these systems can be reversed in the summer.
Yes,
and we can use the same systems to deal with both winter and summer. And nobody really is thinking about that yet. But actually, that is the next step, I think.
So could you see a load of retrofits of heat pumps into existing buildings as a way of?
Well, air source heat pumps only really work when your building is thermally efficient and not leaky. So
good luck with that.
The first thing you need to do is to make it. Otherwise, it's just running inefficiently the whole time.
Yeah.
The first thing you need to do is to make the building. So going back, I'm an acoustic consultant, but for 8 years I've been learning how about thermal and overheating performance and ventilation. So I know. I ended up knowing quite a lot about all of those things, not anywhere near as much as a specialist in, building physicist, but enough to know the holistic approach for all of these things that we talk about is environmental quality. And it's definitely the way forward is some system that it can operate both in the winter and the summer, where you've got these extremes.
So retrofit would look like you might get subsidies for new windows and sealing up the facade or more insulation, and then a heat pump retrofit. If you did that in combination, you might have a chance, right? And
I don't know what's like in North America or the rest of the world, but in the UK there are grants for that, but it's just not been. I think it's fallen flat or not really been carried through sufficiently. But there are mechanisms in place to do that, and and the government understand that. But yeah, I mean, I've become a real, like we're talking about engineering and making engineering cool. Well, I've become a real geek recently with the heat waves and actually trying to really focus on how do I. I've got an existing 1930s building. It's leaky. Fortunately, it's in a quiet area, so at night time I can open the windows. But how do I reduce my heat gains with this existing property? And I see people. I follow people who are actually doing some quite fun things, which is measuring their internal, external temperatures and other environmental qualities. Putting awnings to bring out to reduce to encourage shading. There's all sorts of things that people are doing who are actually reducing their heat gains, and people don't realise that actually in 30 years' time, 2050, it's going to be really really hot and frequently hot. And people will be looking out for seeking those things, those solutions, and they'll become those retrospective fittings. Insulating your property, coping with heat, solar gains, that will become a part of your normal way of working, of DIY work, really.
The thing I wonder about in the UK is there a sufficient electricity capacity to deal with this? Because buildings are going electric, cars are going electric. Where's the power going to come from?
We're not going to talk about nuclear again, Adam.
No, all right. I've got to sell my shares in that uranium mine I own.
Chemical.
but actually, the way of thinking, and I'm pretty sure this is the same for everywhere else in the world, is local generation. It's the centralized generation of electricity. The way we've got set up now is not really efficient for long term, and local generation is the way to go. And PV is a good example.
Yeah.
But the problem is most countries, the infrastructure isn't set up for it. No. So you're suddenly generating a lot of electricity, which you want to feed back in the grid, but actually the cable connections aren't designed to have that energy fed back to the other way. So it's another issue which we bury the cables in the UK. So and I'm sure that's the case in a lot of countries. So you've got there's a wholesale change in a lot of things that are coming in the next 10, 20 years.
Yeah, I think it's a good time to be an electrician in the next 20, 25 years.
Without a doubt. Without a doubt.
Yeah. Okay, man. So we are coming up on time here. So just to summarize, my takeaway is there's new regulations in town. People are slowly becoming aware of them, and the consequences are probably going to be more mechanical ventilation, better design mechanical ventilation, not just, here's a fan from Home Depot, right?
Yeah.
Proper ventilation in homes, better standard of design in homes to account for acoustics and IEQ issues and ventilation issues. There's going to be a run on electricity. He who lives near electricity generation grid is going to be a happy man. There are consequences coming down the pipe here that are going to present challenges.
Well, and I would just add that I'm sitting in the UK, but actually there are other countries that are affected by this, and they're way behind the curve.
Yes.
So North America is going to, unless they enforce these things, it's not going to happen. And the same for Northern Europe. These things are going to have to come for us to be able to deal with the environments we live in.
Yeah, absolutely. Okay, so we normally finish up with a quick fire question each from one of us. So no phone a friend. So question I like is, tell us something about your discipline, acoustics, that most people don't know.
It's not a black art. It's not a black art.
But close.
Everyone says it's black art, and because a lack of understanding. But actually, it's very specific. You give me a set of parameters, and I will tell you exactly what that's going to be, and within a margin. And that really is acoustics. Is the interpretation of someone's perceptions and actually producing information which is accurate to the information, to the input parameters you've got.
Yeah, look, you're in the health and well-being business. You just didn't know that, right?
Yeah.
Everybody in IEQ is.
Yeah. Okay.
So, James, one of the, we've had comments in the past with some of our guests about the importance of teaching kids in high school when you're at a place in your life where you can actually buy a home.
Yeah.
No one teaches kids how to buy a home. There's no education. It seems like society goes through this trial and error, and if you're lucky in your trial and error, you end up with a property that, has a great environment, is energy conscious, right, is set up to deal with future changes in energy sources, but nobody teaches that. That is something that you have to experience, and many, many people have bad experiences. So if you were addressing high school students, they said, James, come on and teach our grade 12 students, a class on how to buy a home, what would you say to them?
Think outside the box. Don't look at the visuals. Think. I always used to visit the houses I bought, considering at night time, in the evening, look at things outside the box, because what you're looking at on paper might not actually be apparent in reality, and you need to really weigh that up. And that includes environmental conditions, that includes your neighbours, that includes the building. It's not just about paying for it; it's about living with. These are spaces that we live in. These are homes we're talking about. So consider all of the factors that come into what makes a home.
Mm. Yeah. Many years ago, I wrote an article. The title was "In a Town Called Comfort, Only the Blind Can See," and the basis of that was I was watching Ray Charles in their movie, and he bought a new home, and I thought, well, if you're visually impaired. And the aesthetics, the visual stimulation is not part of your decision-making process. What is? And it's sound, and it's the thermal environment, and it's the air quality. And from that, I wrote that article in A Town Called Comfort, Only the Blind Can See. But it actually drove our initial engagement with our clients, because we would say to our clients, listen, before you, no pun intended, by the way, before you engage an architect, sit in your own home in the middle of the space, close your eyes with a pen and a piece of paper, and just observe with your other sensory systems what is going on in that space and what are the things that you don't like, because you have a chance here to engineer that out in your new home.
How do you use the space that you're living in?
Yeah, exactly right.
I've got an extension being built, soon to be started, and the architect and the contractor don't like me because I've designed in sound insulation, because I know that I've got bedrooms next to sensitive spaces, and there's all sorts of features that I've designed in for that very reason, that I'm trying to create the space that I understand would work for us.
Yeah, that's great.
I take it you'll be paying over market for all those services.
Materials, over market for materials, yeah.
Well, but this is a good point Adam makes, and again, for our listeners, is that, when we were talking with clients about designing to the standard, and then that design that we would create ended up onto the street, and of course people would have to bid on it, and the builders particularly, or the trades, would say, well, what Robert has designed is an upgrade. And I would say to them in the design charrettes, listen, we designed to the standards and you're calling that an upgrade. That means anything below the standard is a downgrade. And I would look at the client and I'd say, do you want to buy the downgrade? And not one client said that they were looking for the downgrade. Right? So come on, man. Like,
and I see a lot of designs which are just impractical, really. Yeah. That you've got to think about the practicality of it at the same time.
Yeah.
Okay, man. Well, that was good. Thanks for coming on, James. That was excellent. I think,
James,
this is really underestimated, underrated issue that is going to blow up in a few people's faces, quite frankly. Some big developers are going to have some problems with this down the road.
Yeah.
And they just don't know it. They're sort of slowly driving into this mess with their eyes wide open, frankly, right?
Yeah. Adam, I'm going to suggest we get James back on again, because I have a whole bunch of questions here about noise science, the acoustics and decibels and these terminologies that people hear, but they are not quite familiar with it in terms of, this, what is sound pressure, and how do we deal with some of the acoustical challenges that we have in party walls and separation between, I have a lot of technical questions.
What we should do? We should get James back and have an IEQ episode, put a spider diagram up and just go round it and talk about each point.
Well, we could, we should actually do that. We should get, somebody from the CBE, someone from NRCan, get James on the sound.
Workshop a spider diagram.
Yeah, right? There we go.
There you go. It's in the brain. I'm working on it. Okay, man. Thanks very much.
Any opportunity to talk about acoustics or passions of mine is welcomed, and actually, as you said, it's a sense of us all. And it's actually pretty cool. I've designed some really amazing spaces, and you go into them and you think, that sounds really good, and I've done a good job, and people appreciate it. So yeah.
Hey James, I keep you on here. Sorry, it's a field, and I'm probably not going to get the pronunciation right. But it's at sympatics or something, where they'll take, for example, trays of water or sand,
Yeah.
And they'll run noise through the surface of the bottom, so it acts like as a diaphragm, like on a drum. And then the material turns into geometric shapes. What is that?
Yeah, that all that's doing is exciting the modal resonance of the plate. So you've got a plate, a single plate material, and then you're exciting it and the sand or the water, it displays the modal resonance of the plate, and you change the frequency. It's the input frequency, and it will change it will excite a different modal response on the plate. And that actually, what you're seeing with your eyes there is actually what happens in a 3D form in a room.
Right. Yeah.
And the rooms have modal responses in the X, Y, and Z axis.
Yeah.
And you sit in a corner of a room, and it's biased towards low frequency because that's where low frequency modes are most prominent. There's a whole heap of things we could go into about acoustics, which I'm very, very happy to talk about, which are cool, and actually which things that we all experience in everyday life, which we don't realize we're actually experiencing.
Yeah, it matters, but people don't know how much it matters, right? This is the thing.
Right.
There's an awakening that needs to happen here.
Yeah.
Okay, man. Listen, thanks very much for coming on, James. That was awesome.
That's all right. Thanks for your time, everyone.
The Edifice Complex will continue in just a moment.
Are you struggling with paperwork, spreadsheet overload, and project management? Then Blue Rhythm is the solution to help you. Streamline your commissioning and project management process. Go paperless. Increase efficiency and save money. Blue Rhythm is commissioning and project management software by practitioners for practitioners, adapting to your workflows and processes, and doing things your way. Blue Rhythm provides painless and fast onboarding by bringing your existing workflows, forms, checklists, and issues logs into Blue Rhythm for you. You can use their pre-built templates to customize your commissioning workflows. And Blue Rhythm can fully handle the transition from your current software platform. Blue Rhythm is secure, scalable, and reliable, backed by amazing support, and accessible 24/7 on any Windows, iOS, or Android device. Why are you still using paper and hard-to-control spreadsheets? Start your free Blue Rhythm account today at bluerhythm.com.
Are we there yet? Yes, we are. The future promised real-time monitoring and control of our buildings, and now that is a reality with Sensor Suite. The only question you need to ask yourself is, how much energy and water is my building wasting each year? Sensor Suite will do the rest. With Sensor Suite solutions, any existing building and equipment can be retrofitted with smart sensors and controls that generate an industry-leading high-resolution data feed, unlocking a level of operational optimization and visibility across your entire building portfolio. This allows analysis and targeted interventions that turn old analog buildings into intelligent, energy-efficient grid resources, allowing monitoring and control at your fingertips through Apple, Android, and Windows devices. Make a difference to the environment and start saving money today. Go to sensorsuite.com or call toll-free 1-855-773-6767.
And now, back to the show.
Acoustics is such a great topic. Obviously, James has a great background in it. I could talk with him and just keep asking him questions for a long, long time. And when he's like this whole thing about sleep disturbances, sleep deprivation due to sound, but also the other indoor environmental issues too, is huge.
Listen, if you did a Google search, sleep books, sleep as a health topic has really come onto the fore in the last 5 to 10 years, right?
Yeah.
People are really finally starting to work out that, 6 hours a night doesn't make you golden gecko. It makes you mentally retarded.
That's my problem. I had to come to you, Adam, to figure out what the hell was going on with me.
Yeah.
I was thinking about 10 years ago, I did a sleep study because my sleep hygiene was crap. And but as it turns out, my brain is one of those brains that doesn't turn off. Like there's, they know through sleep studies that the average person has, and I don't remember what the number is, but there's what they call arousal rate. So as you go through your sleep cycles, right, there's an arousal rate. Right. And some people have a few, and they can get into really deep sleep for long periods of time. They go through their cycles and it's normal or better than normal. But my brain just doesn't shut down at night. And so
do you have trouble sleeping long long periods?
Yeah, that's the challenge for me. So we worked on not only in terms of sleep hygiene, but also, just other aspects. But part of it was being in a space that was dark, quiet,
cool. Right.
Cool.
So for good sleep hygiene, you need your temperature to drop 1 or 2 degrees C.
Yeah.
Space, right? So you need like 18 degrees C in your bedroom, quiet, jet black, like no flashing lights. Get rid of that TV. I do all this
phone.
stuff.
Get rid of the
I sleep like a champion.
So anyway, so the whole subject matter is incredibly important. And as we sort of introduced at the beginning when we were introducing James, it is still the number one problem in buildings today, despite all the fact that we're going through this huge global pandemic. Sound is a problem. And but it's a problem that has an engineering solution to it, right? It's not new shit. Like, we know what it takes to engineer out noise problems, but it's got to be done at the beginning. Both you guys were talking about trying to solve the problem, but the existing inventory of buildings, I don't know. That's just a subject that's so big.
The point here is the problem is known and the solutions are known, right? It's a money issue and a will to do it issue, right? So the will to do it will probably be solved for you. The governments will just legislate for it, right? So that will solve that problem. Then it's a money and a do it, get it done job. But what the key takeaway here for everyone is, this is not a noise issue. This is not a building issue. This is a health issue.
Absolutely, without a doubt. Yeah.
This is about your health and your well-being. Good sleep is linked to longevity. It affects heart, brain disease, everything, man. Just that alone makes that subject everything you need to know. So IEQ, I think, is one of the most underrated design parameters and concepts out there. It's something they give lip service to. If I was king of lead, I'd get rid of IEQ point and I'd just make it all about IEQ.
Yeah.
That's there. There you go.
Yeah.
President of Lead, I hope you're listening. I'm sure you're not.
Sure, you'll listen. You'll have something to say about that.
Exactly.
Awesome.
Okay, mate. Listen, we better wrap it up there. So I shall see you on the next one.
Thanks, Adam. Cheers, man.
Okay. Cheers. Bye.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. If you have enjoyed this podcast, please leave us a review on iTunes. See you next time.